at the average rate of change for a function. Let's suppose we have some function f of x between 2 points x equal to a and x equal to b. So I'm going to pinpoint 2 points on the x-axis. The rate of change is f of b minus f of a over b minus a. I'm going to figure out what the function output is for each of these x values, subtract that divided by subtract a and b. This is very similar to slope. In fact, it's the slope of what's known as a secant line. If I were to pick 2 points on a function and draw a straight line between them, that's known as the secant line. And this average rate of change tells us the slope if we were to draw a line between those 2 points. Let's look at the average rate of change of the function f of x equal to x minus 2 squared from x equal to 1 to x equal to 4. My first step is to plug these values in. 1 minus 2 squared is the same thing as negative 1 squared, which is the same thing as 1. When I plug in 4, we have 4 minus 2 squared, which is the same thing as 2 squared, or 4. So we have f of 4 minus f of 1 over 4 minus 1. In this case, our average rate of change is 1. This time, let's look at the average rate of change between 2 and 5. F of 2, that's 2 minus 2 squared, which is 0. And f of 5 is 5 minus 2 squared, which is the same thing as 3 squared, or 9. So when I find my average rate of change, I have 9 minus 0 over 5 minus 2. In other words, 9 over 3, or 3. Next, let's consider the function f of x equal to 2x plus 5. By finding f of 0, we have 2 times 0 plus 5, which is 5. For 1, we have 2 times 1 plus 5, which is 7. So my average rate of change would be 7 minus 5 over 1 minus 0, which is 2, the exact same as the slope of our original line. This time, let's look at the average rate of change from negative 3 to 1. F of negative 3 is 2 times negative 3 plus 5, which is negative 1. And f of 1 is 2 times 1 plus 5, which is 7. So we have 7 minus negative 1 over 1 minus negative 3. In other words, 7 plus 1 over 1 plus 3, which is 8 over 4, or 2. Once again, the exact same as the slope from the original line. And this will always be true. The average rate of change for a line is the slope. The average rate of change is just a way to generalize an idea of slope to more complicated functions.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.